chapter 10.1%. So in this chapter, we're going to go through just what is a percent in the first place, but then we're going to look at different problems we can use percents in order to solve, how to work with them in word problems, percent of versus percent increasing and decreasing, etc. So first, the basics of percents. The word percent comes from the Latin per centum, which means per 100. Thus, a percent is actually a ratio of some number with 100, and a ratio just basically means a fraction. So 15 over 100 can be read as 15 per 100. The fraction bar can be read that way. We're going to talk about that a little bit more later. But 15 per 100 is 15 per cent. So x per 100 will then be translated to x per cent. But not every number is quite as simple as that when it's given to you as a fraction. So let's talk about converting from a fraction to a decimal to a percent. So if we're starting with a fraction, we divide the numerator by the denominator to get that decimal form. We can use our calculator to do this. Then we multiply the decimal by 100, which moves the decimal point 2 places to the right. That's what multiplication by 100 essentially does, is it just moves our decimal place over because of our powers of 10, our place values, and all of that. And then we just tack on a percent sign. So 67 over 100, using the rule I said here, is going to be 67%, but let's demonstrate that using this process. So 67 divided by 100, throwing that in our calculator, is going to be 0.67. Then I multiply by 100 again. So it's really just going to move that right back to the 67. So 67 divided by 100 gets us 0.67. Multiplication by 100 will move that decimal over to the right to give us 67 again. So tacking on that percent sign, 67%. But now let's look at one where it's not as obvious. 31/20ths, right? So this is actually an improper fraction. So if you know anything about percents, you might expect that this will actually be over 100%, but let's see how that works. 31 divided by 20, throwing that in our calculator, will get us 1.55. Moving that decimal over twice by multiplying by 100, again, you can use your calculator to do that part, but it's good to understand conceptually what's happening, will get us 155. Tacking on the percent sign, it's 155%. So it's more than 100%, because 100% represents a whole, right? Just like 1.00 is the whole, right? And I move that decimal over twice, it's 100. That's what's happening. Okay, so we've got an improper fraction that would be 1 in 55 hundredths, we could write it as if I wanted to convert it back into a fraction. But we'll get into that in a little bit. Now 15/16, similarly, do that division, and we're actually going to get one that has a lot of decimal places, okay? But I still do the same process where I'm going to move over twice, right? Just twice. So that means I'm going to be left with two things after the decimal, 93.75. But that's fine, 93.75%. You can have a decimal within your percent. And in fact, on the next page, we're going to see a fraction within our percent. So that can happen too. So if I want to go from percent to decimal, I just remove that percent sign and divide the number by 100, which is equivalent to moving the decimal 2 places to the left. So basically, I'm just doing the reverse. I'm moving the other direction, okay? So 35%, I'm going to take my decimal, but where's the decimal? Well, remember that 35 is the same thing as 35.0, right? That's secretly there. There's a secret decimal right here. So I can move it over twice, so I'll get 0.35. But where is that coming from? It's 35 divided by 100, which is 0.35. 69.8, similarly, 69.8 divided by 100 will end up moving that decimal over twice to the left, which gets us 0.698, right? So everything ends up after the decimal, but that's not always going to be the case. 325.77%. Once we have 3 digits in front of any decimal that's inside the percent, that should tell us we're going to have a whole number left over. So when I move over twice, I end up getting 3.5 0.2577. So there is a number that it's greater than 1 in this case because this was greater than 100%. Now 1/2%, in order to do this, it's best to convert the 1/2 into a decimal, then convert that percent into a decimal. So like you're doing a double conversion. So 1/2 is 0.5, but it's still a percent right now. This is not its decimal. This is something you have to be very careful about. This does not equal 0.5. It equals 0.5%, which is different because we need to be able to move over. And there's nothing there to move over to. That's interesting, right? So how do you work with that? Well, 0.5 is the same thing as 0.5. I can tack on as many zeros as I want there. So now when I move it over, it's going to make a little more sense. So when I move that decimal over, I just plop that extra 0 in there to get 0.005. Okay? So, often, like, this is a very small number, so that's something to be aware of, the difference between, like, what a 0.5% is, a decimal within a percent, decimals not being equivalent to percents, but you have to do that change. That's how you can often get confused when dealing with, for example, like interest rates and stuff like that. Like a common interest rate might be 5%, right? And so what does that look like in decimal form? Well, 5% is 0.05. But you could also end up with an interest rate that's actually 0.5%, which is that 0.005%. So you have to know the difference between 0.5% versus 5%, right? There is a big difference there. The amount of money you're going to make is very different, right? So being aware of how those decimal places affect the percent is pretty important when you're dealing with financial stuff. Okay, speaking of that, let's talk about percent change. So the percent increase or decrease, which together we call percent change, over a period of time is found using the following formula. So percent change is equal to current amount minus old amount over old amount, and then we kind of just times 100%. So if the current amount is greater, the answer will be positive, which is an increase. If the current amount is less than the old amount, then the answer will be negative, and so we've decreased, right? So you can have negative percents. That will happen. Usually we're going to run into this type of thing in word problems. You really have to pay attention to this, okay? So in 2014, the Major League Baseball team with the most improved record for winning was the LA Angels. In 2013, the Angels won 78 games. In 2014, they won 98 games. Determine the percent increase in the number of games won by the Angels from 2013 to 2014. So a couple things to think about here, because the most common mistake to make in these problems is to end up with a negative number when you should have had a positive number. So you got to make sure you're, doing this in the right direction, essentially. This explicitly tells you we're looking for a percent increase, so it should be positive. But we should also kind of see that the old amount in 2013 was 78. The newer amount, they went up in 2014 to 98. They increased their amount of winning games. So their percent should be an increase. It should be a positive percentage, right? Positive improvement. So now, and with that in mind, we're going to label this, that our current amount is going to be the one that is the most current. That's what I mean by current amount. It's like the one we're sort of comparing again, the one that is the changed version versus the old version. Okay? So current and old are the terms I'm going to use. You might see this same formula using different words. The point is it's like the reference amount versus the amount that we want to compare with, or there isn't like a good word for this, but I'm going to go with current and old because a lot of these A lot of these problems have to do with time, and so current and old kind of gives us a good idea. Okay, so our old amount is the one that happened previously, so that's 78. Our current amount is the 98, even if 2014 is not current. Okay, now, so I'm coloring them in. 78 games is red, 98 games is green to match with the current and the old amount. Now, I just plug into this formula. That's all I have to do, is I just have to replace the words current amount and old amount with these numbers. So 98 minus 78 over 78. So 98 minus 78 is 20. 20 over 78 is 0.256. Multiply by that 100 to kind of move my decimal over twice to get 25.6%, right? That moving the decimal over when I multiply by 100, right? So I want to just break this down a little bit more. That 20 over 78, you might, without even using this formula, because I don't want to get bogged down by formulas here, what's happening here is they increased by 20 games. Like they won 20 more games. We can see that, 78, 98. So there's 20 more. So they increased by 20 out of 78. What is 20 out of 78? Well, that's what's in this formula. That's all that happened, right? So out of the 78 that they originally had, they have made this increase by 20. So that's kind of what's happening. So you don't necessarily have to think formulaically, just think about exactly what's going on and why we would want that 78 on the bottom, because we're referencing the old number. That's the reference number, is again another term for that, versus this new, they increased by 20 from that reference. Okay. Another place that this formula gets used is for percents markup and markdown, which is basically like in stores and sales. You get a current price minus old price over old price. So if we're referencing an old price, we want to know if a new price or a changed price in some way is more or less, has been a mark up if it's more, mark down if it's less, like if it's a discount, we plug into this formula. So we have a store buys tables from their supplier for $48.76. They normally sell them for $79.88, but now they're on sale for $69.99. So first, what is the markup percent from the supplier? So in other words, the store buys it for $48.76. Normally, how much markup do they do when they sell it? What percent more than the wholesale, than the buyer price would it be? So to figure that out, our reference amount, our starting amount, will be the supplier's price, $48.76. And our current price, or the changed price that we're looking at, is the $79.88, because that's going to be our normal markup, okay? So in other words, we get this formula. So if we start from that $48.76 price, that's our supplier price. How much change has there been to get to the normal price of this table at this store? That's the difference between $79.88 and $48.76. Okay, so $79.88 minus $48.76 is what, 31, 22, I think, something along those lines. I think this is 31.2. No, it's not. It will be 8, 9, 10, 11, 12, 13, 31.14. That's not true either. 2. There we go. 31.12. There we go. I can do that in my head. So we get 31.12 divided by 48.76 times 100. We end up with 63.8%. Okay, that makes sense. It's a positive value because they made their price higher, which makes sense because the store wants to make money, right? They want to make profits. They have to sell the table for more money than they bought it for, or else they're not making a profit. Now, what about the sales value? Like when they put this table on sale for $69.99, what percent are they making, percent of profit are they making? Okay, so again, our reference value is the same because it's starting from the supplier value. How much more are they selling it for if it's on sale, if it's the discounted price? So now the reference value is that $48.76 still, but it's now $69.99 is our current price that we are comparing to the reference old price. Okay, and so this one ends up being 43.5%. Again, this makes sense to be a positive value because they would want to make that profit. If it's a negative value, then they're selling it for a loss, and that's not what they'd want to do. But it also makes sense that it would be less than the normal markup price, right? Because they discounted this. So they're going to make less profit because they're selling it at a lower value. Okay, now what about the sale markdown from the normal value? So in other words, what is the actual discount? What if I the consumer go into this store and I buy the table on sale, what percent discount did I get? So now I'm referencing the normal selling price, $79.88, and my current price is the $69.99. So the old price is changing to the $79.88 because that's what I'm referring to as my old value, and my newer value is the $69.99. Now notice when I do this, $69.99 is a lower number than $79.88. So when I do that subtraction, I end up with a negative number. Multiplying by 100, I'll end up getting negative 12.4%, which again, essentially means they discounted it, right? A negative means it's a mark down. So I wouldn't say, the discount was 12.4%, it was negative 12.4%. Usually we list it positively, say there's a 12.4% discount, because that makes more sense. But really what happened is the price went down by negative 12.4%. Like that's really what happened. Okay, so the last thing we're going to talk about is the use of percents in word problems. So we already saw a couple word problems here. But in general, word problems with percent word problems can usually be simplified in some way to a single sentence that can be translated directly into an algebraic statement. So we've got English phrases and then there are math meanings. The word is basically the word equals, or like in math, we just replace that with an equals sign. Percent of means multiply by that percent. Percent less than means multiply then subtract. Percent more than means multiply then add. So what I mean by that, and we're actually going to see some types of examples of that in later chapters, but percent less than or more than means I will multiply by the percent and then I'll add it to my original amount to say if I'm 50% more than something, I have to figure out what is 50% of that and then add it to it to get percent more. And if it's for 50% less than, I have to figure out what is 50% of it and then subtract it. Another word to remember is anytime it says the word what or how many or whatever, how much or something along those lines, our question words, that's what gets translated into our algebraic x variable, okay, in these sentences. So, here I have, for example, Melissa wishes to buy a condo for $189,000. To obtain the mortgage loan, which is the type of loan for a house, she must pay 20% of the selling price as a down payment. So this is a very common real-world thing that you have to pay at least 20% as a down payment in order to buy a house. You have to be able to provide that amount in order to purchase a house, even if the rest of it is on loan. Now, we want to determine the amount of Melissa's down payment on this $189,000 condo. Okay? So I'm going to break this down into this single simplified sentence that this is asking. Now, there's multiple ways you could say this, but the way I'm going to say it is the down payment is 20% of the selling price. Another way you could say it is, what is the down payment? Sure, but we want to throw that percent into this sentence, right? So the down payment is 20% of the selling price. That's what this is saying, right? She must pay 20% of the selling price. What does that mean? The down payment is 20% of the selling price. Okay. Notice all these words. Is our equal sign. Of is our multiplication. 20% we're going to convert into a decimal. Down payment and selling price. One of those is our unknown, right? We want to know what our down payment is, so that's basically our X value. That's our unknown value. But the selling price, that's $189,000. We know that number, so we can just replace it. Like so, right? Now, down payment equals 0.20 times 189,000. 0.20 times 189,000 is something I can throw directly in my calculator. It's 37,800. And we're done. Down payment is $37,800. I don't need any more than that. So if I can break down these percent problems into one simple sentence that uses words like this, then it's just direct translation. Each of these words has a meaning. And if there's one we don't know, then that's the one we're trying to find. So don't get thrown off too much by these word problems, right? There's a lot of words here, but usually they can be simplified down to a single sentence when it's these percent problems. And you just have to do a quick translation and then maybe solve a little bit of an algebraic problem. But usually it's fairly simple algebra where it's x equals some numbers, or maybe the x is on the other side, but most of the time it's not.